Okay, let's start with closing the windows because there is a nightmare. Yeah. Will you please shut the door? So, sorry for starting late. I was held twice until I came here, so that's why I late. Last week we had a test. I will give you points and everything very soon, perhaps during the holiday. Okay, I sent you messages because there are new people. They're arriving because the visa is late and everything, and perhaps they didn't get the fundamental information how to get a grade passing the exam, what are these tests, and where are the materials. So that's why I sent you messages to everyone. Very interesting that the new people, half of the new people, is added to the teams, but the half of them not. And I didn't see any difference between them. It's funny. Okay, that's one thing. Yeah, yes. Okay. So it's self-hypnosis. I will evaluate the grade and test during the holiday. I will do it. Don't worry. And you don't see anything because I haven't pulled down this one. Could you read the solutions of the test, because I uploaded it. My handwriting is not perfect. There is no warranty that everything is right that I have written, because I just went through and did myself the test. I will correct it. And also we'll do the homework exercises. And if you have any problem with this test, then you can do it again after 8th of December. Okay, last time I talked about matrices and I had lot of information. And when I prepared yesterday for this class, then I meditated what to do. So there are 6 lectures in this semester and 6 practices. Actually it's 5 because you will write a test. So I slow down and now I will tell this matrix stuff again with more examples and everything. And also tomorrow we will have a practice and you will understand this. It's necessary because I have a sheet of the second test. And if you don't understand what is matrix and how to do matrix operations, inversion and a lot of things, you will not pass. So that's fundamental. And also operations with matrices are very, very important in your life. I mean, when you are a physicist, chemist, or you just you are doing something more difficult task as a programmer, software developer. Yes. Okay, I will not repeat what is a matrix, but this transparent stuff is very important. We will do some examples with it. So I have a matrix. And it's transparent. Basically, just a mirror on this on the main diagonal. So it means it's nothing more. And if you have just a square matrix. So it's nothing more than just changing the rows and columns. That's the transformant. It's simple, very simple, but necessary. Here, oh, yeah, of course. It's a 3 times 3 type matrix, and this is a 2 times 3, and it becomes 3 times 2. So it's important. The changes usually and everything in the test will be restricted for these square matrices, but there are more. There are more stuff like this. Okay, that's simple. Operation. There were 2 very simple operations. Bless you. And one is add together 2 matrices, multiply with a number, and there are more. It's coming soon. Actually, that's not bad. Next class will be in another building, and I have an iPad to pull and release this sheet. Okay, so I have a matrix. I have a B matrix. Oh, here. If you want to add them, it's very, very simple. You just add the elements. By the way, what do you think about the test? Was it difficult? Not? No?
I think I have one thought about the test. Well, when we do our exercises during seminar,
Yes.
they are in Hungarian. So we just see how you solve it, because you understand it, and it's, at least for me, sometimes I do not fully understand what was the task. I see the solution, I understand the solution, but what exactly was the task? Yeah, and when we see it in homework in English, if I had, well, for example, I had a misconception about how to solve one, and I had no
I don't have infinite time, and you would need an English lecture. Now, next year you will have. If you put together my slides, that's okay. But about the task, yes, I will write down the task in English, and then you can write it down. But the better solution would be if you would get it in a digital form. Okay, I will, yes?
Maybe you could give us like an answer to the homework. Maybe
I will, you know, I wanted to do it, but I'm a human.
Yeah.
In old days, when I was younger, I could work with 3 hours sleep. Now I could, but only once per week. Usually it's that day. Today I slept more, and I haven't had time to fix and give a solution. The best way for practice would be to use LaTeX, and there is another stuff. Some of you, I don't know the name in Hungarian or English, but some of you made notes on. Perhaps you made notes. No, not today. What is the name of this?
What do you mean?
This one. This is
It's a tablet.
it's just a tablet.
Yeah.
But some of you, is this a tablet? Just a tablet.
Yeah.
There is something. It's not a tablet. It's not a computer, but you can write. It would be much better to write and take notes on it and write everything, and it would be more readable, and I could be able to provide you more information. It's quite difficult to me to write with the chalks on the table. Okay, I know this. I will upload the solution. Next time when I give you homework, I will give you a solution too. And I will write down the task in English on the table. There was something else that I didn't do. For the Hungarians, there are 140 students in this subject, and there are 2 other people who give the classes, the practice. And they had a trial or probe test. I didn't do this because I thought we don't have time, but it seems to be there is time. I can do it next time or something like this. Okay, thank you for your comment. It's a bit weird. So I started here, just got you. Fortunately, I got the notes in Hungarian and the task. And everything is just... Yeah, okay. Yesterday, something perfectly different. Yesterday there was a national holiday. Do you know why was a national holiday?
Soviet Revolution. Like 1956 Soviet Revolution.
Revolution and freedom fight against this Soviet occupation. I don't know whether there was any celebration here. Well, if you check the history, actually it's important in this political system, who was in which side. There was one totalitarian system between 1949 until 1956, and there was another softer until 1989, which is funny. Until the recent years, we have the same constitution that Stalin gave to Hungary. Hungary joined to the European Union with that constitution, and it was changed a few years ago. Doesn't matter, it's not important. The important is the matrix operations, and the other thing is to multiply, for example, can you read this?
Yes.
Multiply multiply matrices with a scalar. It's very simple. You just multiply all elements. I hope you can read it because of the light. That's simple. Which is not simple is this. Oh. This is many possibility to make a mistake. So you have two matrices and you do the matrix product or multiplication. It's more difficult. If you want to get one element somewhere, then, for example, here, this one, then you have to start here and also here and multiply this element, the first in the first row in this column and the first column in this row, and then add the next one, the second element of this row and the second row in this column, and go through and then add together. That's is written here, also written there, and that's a good opportunity to make mistakes and you will do it many times, don't worry. But after this class, you will be able to use Python or MATLAB or Mathematica or anything. Well, on Friday, I gave some exercise to my Python course, this Gauss elimination, and so on. They were not so happy, but the algorithms are understandable. Okay, so I have one matrix A. It's and I have another matrix and I want to multiply them. Who said? You. Thank you. Then that's the solution. There will be this tomorrow afternoon. We will do this, and so the question is always. That's very important comment was what you gave, and also thank you for your remarks. Multiply these matrices if is it possible. Okay, so what can we do? Transpose. I don't do it. So now I can do it. Not easy. Oh. This is our only hope. This is very good. I had this product, and the size of the matrix is different than the original one. Okay, but we have more simpler, less simple, doesn't matter. I have these matrices, and I do the multiplication okay. And the last column and the last row. Okay. Okay, if I didn't make a mistake, then that's the solution. What is interesting? It's not linear algebra, actually. I have a matrix. The matrix has n times n element, it's square matrix. And for each element, I have to do free multiplication. And additionally, two sums means you will do this from numerical analysis or if you learn algorithms. So if you have a matrix, then two matrices, then for the multiplication, you need the size is n times n, and for each element you have to do 2n minus 1 operation. If you calculate this, you get this result, but for large numbers, very large numbers, the elapsed time, the necessary time for computation, you need n cubic over 3 operation. So if you have a matrix and it's 3 times 3, then you will get a time. It doesn't matter how much is it. If you have a matrix that's 300 times 300 times, then you need 1 million times more time to do the same operation. It's not exactly, but this ordo number gives you the efficiency of your algorithms. There are more efficient algorithms many times. I tried to explain you at the Gauss elimination. It's good here and in the test, but for computers it's not so good. You have to do such a calculation. I will not ask this in the test, and it is not part of the material. This is just something interesting. At least for me, it's interesting. Okay, I changed the order. Matrix operations. That's very, very interesting. You have multiplication, and if you have square matrices, 2 times 2, 3 times 2, 100 times 2, you can do the exponentiation. I cannot pronounce it, doesn't matter. It's exactly the same like scalars. There is, if it's 0, then you got the identity matrix. If it's 1, then you got the same matrix. And yes, and if it's higher, then you got the same. Okay, this. Yes, I realize you cannot see, but I'm telling you. Yes?
Did you start with the recording for this?
Yes, yes. Thank you very much for telling me. Yes. Thank you. Thanks. Yeah. That's okay. Yes?
The complexity that you wrote, you usually use it to define the complexity of a code that you write.
Yes.
But what's the matter with the matrices? How it's related to matrices, like adding the complexity?
I think the calculation, the matrix calculation. You have an n times n matrix. That's okay. You two matrices n times n. That's the size. And then you multiply it. For each element, you have to do n production and 2 addition. It's for 3 times 3. It means 2n minus 1 for an n times n matrix. Is it okay? Do you understand? And then if you do the calculations, you got a number, it's something 2n cubic minus n squared. You negate the smaller terms, and then you got that the necessary time is depending from the number of elements, not the number of elements, the size of the matrix. It's not linearly, not square, but cubic, and that's not good actually.
Well, if we change n to a specific number,
Yes.
in programming,
Yes.
it will be like equivalent to 1. Like 100 is equivalent to 1.
To one? No.
No?
If you write, it's about comparison. You have just, I told you, a matrix. It's a square matrix. The size is 3 times 3. You do the programming. You got a number for the necessary time. Then you change for example, 300 or 3000. The size of the matrix. So you will have a matrix 3000 times 3000. And then you will need, not exactly, but 1 billion times more time to get the result.
Yeah.
That's it. Did you? Okay. There is this Python. I also study Python, but Zara teaches you the Python. Everyone?
Yes.
Okay. You have fundamental algorithms like searching maximum or add together elements of an array. You have this, don't you?
Yeah.
There is shorting, bubble short, for example, shorting the elements. You learn something like this. I don't know exactly what Zara teaches because we are 4, and the 4 people teaches in theory the same, but it's very, very different. So it's the personality of the lecturer. The tutor is in this course. The for shorting, you have different algorithms, and there are quick short. That's, for example, this n is not n cubic, but n square.
Yeah.
But Zara didn't explain you. This is about the efficiency of the code. And this is not the task written in our algebra class, but you will be programmer and you will be scientist, so I think it's necessary. This is one of the there are 2 more very important things in a good programming. You can usually scientists use brute force. Oh, the code is working. Yes. For very simple programming, efficiency is important, and the data structure. The data structure came from the graphs. Do you learn graphs? Something networks? No. Networks? No. Trees? Binomial trees? Not yet. You will. The structure of the data is very important. In Python, you can use lists. You learn it. There are sets, there are dictionaries, and there was something. Yes, for example, choosing the appropriate data structure is very important. Then you spare time to write the codes. Have you learned object-oriented programming? Yes, but in this class, this Python class. that's something else. But I don't want to continue this. You will run this. Yes. Well, when you finish this, note that so the how to multiply a matrices or what is a matrix is not the most important things. You will have a board exam at the very end, and we will ask what is what network is what view do you have point of view do you have about informatics. Whether you can use informatics for linear algebra to fix a problem. You start fix a program with Java or C++ or Python. Do you know when to use a database? When do you use just an ASCII file and something like this? Okay, this is something like this. I left the boundaries of my subject and my class and told you something else. Okay, this one. This is very interesting actually. I told you many times, if I have an operation, and it's a plus or just a dot or something like this, never imagine that it's that the plus means sum and the dot means production. Or it's not that production that you think. Okay. First, I have a matrix, and because I'm not a masochist, it's a very simple 2 times 2 matrix. And the question is what is this object? So that is I do this because it's easier to me. Okay, so that's actually very simple. 2, 2, it's 4, 0, 0, oh. So it means well, this is it. This is not about that I just put the element on this exponentation. I really multiplied it, just I choose a simple matrix. Okay. Equations of matrix exponentation, you know this from secondary school. If you have 2 matrices with different exponents and you multiply to each other, then you just add together the exponents. If you have just exponentation for a matrix and you do an exponentation, then the result is the product of the exponents. I will not calculate this, if you don't mind. because there are more important things to do. Yes, and you don't see that I talk about it. So again, what's this? So if you have this this exponentation and this exponentation, you do the product, then you add together the exponents. If you do the exponentation and do an other exponentation, then you just multiply the exponents. Doesn't matter. It's familiar. It's familiar. It's the same like you had done previously for other objects. Okay, now this is important, and this is the identity matrix. And if you have an identity matrix, then you can define a matrix that you multiply with the original matrix, and you got the identity matrix. This is not simple. This is the inverse matrix. And okay, there are some stuff that's important. Square matrix exists, okay, and the inverse exists only if the determinant of the matrix is not zero. The matrix which has an inverse, it's a regular matrix. The other is a singular matrix. And now the more important things. You can calculate the inverse matrix at least two ways. One is the elemental transformation. You can multiply each row, which is not zero, with a scalar. You can add lambda times of a row to another row, and you can change rows. And this is what I think here I had an example for this last time, and perhaps I didn't have an example for the next one. For the I had something for the subdeterminants. Only the ranks was not given. So I have first a quite simple matrix. And I'm looking for the inverse matrix. That's the question. So what I do, I write this matrix here. I draw an identity matrix here, and then I do operations to transform this matrix for an eigen matrix. That's the purpose. So, first, I want to remove this number. So what I do is this. So this is the same. Okay. And then I remove this. Then that's 0. It's minus 3. That's minus 2. And this is 1. Okay. Next one, I want to this, but I'm quite lazy. So I decide to multiply 3 the first and multiply 2 the second. It's allowed, it's okay. So 3, 6, 3, 0, that's okay. And with 2 minus 6, minus 4, and 2. And now I just add the first and the first row to the second. So it will be 3, 6, 3, 0, and then it's 0, something is wrong, and the something is wrong is that I should have calculated the determinant of this. And what is it? So it's it's minus 3. That's okay. Then something is not good. Oh no, no. So the second equation is added to the first equation. Then this is 3. This is 0, this is minus 1, this is 2. So now I multiply the first row with my 1/3. Multiply the second row with minus 1/4. Okay, so this should be the result. This should be the result. But I'm not sure. Not sure. So I have this matrix here. And for check, I do the multiplication again. Oh. I have a bad feeling that something is wrong. Where do you see?
The first row and second one. Minus this, and you change it to minus 4.
Yes. Wait.
Minus is right.
So it's I multiply this 3, 6, okay. Then I multiply this 2 minus 4 and 2. It should be good.
And you 1 plus 2, row 1 plus row 2 equal to, in the row 2 you 0 minus this.
This is this should be 6.
Yeah.
Yeah, thank you. Because I remember everything was with one third there. So it means I change this minus 6. So that's okay. And then this is 2, 3. And this is yes, and then this is because I did something similar last time, and it was something like 1 minus 2 minus 2 1. Thank you. Look, it's easy to make a mistake. And then this will work because I had done this previously. Yeah, that's minus 3. Zero, 0, minus 3, and then 1, 1, 0. Okay. This, thank you. This was the. I will do more example in the practice tomorrow. So what we had done, we have a matrix. We wrote this matrix and the eigen matrix. And then we, with all of transformation, modify this matrix to an identity matrix. And we do the same operation on both sides. And in this side, we will find the inverse matrix. Okay, next one. Next one. Subdeterminant. It seems to be more difficult, but if you have an algorithm and you can calculate determinant quite quickly, then it's better. So let's do the same. Okay, so I have this. Yes. You have telepathic abilities, gifts, because I'm talking and you know what I'm talking about without the projector. Okay. So what I did is elementary transformations. Now what I want to do is a calculation of inverse matrix by subdeterminant. the determinant exists and it's free. We had done previously. Great. And for each element, we calculate the subdeterminant. What is the subdeterminant? I have this matrix, it's very simple, and I take the first element of the first column and row. I did everything, and I got this. That should be the subdeterminant. It's not a determinant, it's just a number. I have to divide it with the determinant, all elements. So the subdeterminant of this is this. In the second column, first row, the subdeterminant is this 2. Then I did it for the second row, first column. I did it the first column and the second row. I got 2. And for the second row and second column, I did it the second column, second row, and I got the subdeterminant. That's not a determinant, just a number. It's 1. So with this method, it's here. I forgot something. Yes, thanks. Yes, it's here actually. So it is here. It is here. This. Okay. Full destruction. Excellent. I don't know what to do. Okay, so it's the same. And in this case, it was quite quickly. I will do more tomorrow. Because, okay, we have 8 minutes, and there are some statements. I will do this tomorrow about the transponents and the inverse of the transponents and everything. It's not so important. It's important, but there are more important things. There is something called rank. This rank is an important number for the vectors and subspaces and the matrices. The rank of this of an n times n matrix is the rank of the row vector system. The row vector system is you got from the rows of the matrix. You just turn the rows to vectors. And how do you calculate this? So this is the last thing that I want to show you. And no, here. It's weird because question, what is the rank of this matrix? And what we should do is similar to this, what we had done previously. It's Gauss elimination. Just remove the unnecessary rows. So here I take the first row and multiply 3 and add to the second one. So it will look like 1 minus 2, 3, and this is 0, this is minus 4, and this is 10. So here I cannot do more here. Oh, sorry. If you have this matrix and you calculate the ranks, you can do some fundamental operations. You can multiply the rows, if you want, with a number. You can multiply a row with a number and add to the other row. You can change rows. You can also change columns. And what is the purpose? The purpose is to transform these matrices in trapezoid form. This is a trapezoid. Trapezoid forms means like it means triangular form for square matrices. So it means you have the main diagonal, and the main diagonal and above the main diagonal everything is non-zero, and or 0, doesn't matter, but below everything is 0. And if you have this form that I just got, then the rank of this matrix is the number of the rows. And for here, the number of the rows is 2. So this is 2. And this transformation do not change the rank of the matrix. Okay? And I think I over with time. We will practice this tomorrow. Okay? I hope this helped. I don't know how much did you understand last time from my lecture, but it was a lot of information. We will practice this. So, see you tomorrow. Thank you very much. Class is dismissed.